in that video of the introductory session. So let's have a brief intro one more time. So as you know that could you see my screen?
Yeah, I can see that.
Okay, great. So as you can see out over here, that the scenario is quite simple. That AIX is also one of the Unixes which is available in the market, and as other Unixes, AIX is also hardware dependent or hardware proprietary software which runs only on a specific set of hardware, not on any other hardware. Like if you have Windows or Linux, you can place it on any hardware. It may be what I can say IBM's hardware, Dell's hardware, HP's hardware, or Sun's hardware, or any other platform, whichever you like. But unlike them, IBM AIX works only on a specific set of hardware, that would be your P series hardware. So again, when it comes to IBM, there are three types of hardware series. One is IBM X-series, other is IBM P series, and Z-series. Nowadays what happens is IBM X-series have been sold out to Lenovo, so no more it is called as IBM X-series, but now it is called as Lenovo X-series, and generally used for Windows and Linux platform, 32-bit and 64-bit architecture. Whereas when it comes to IBM P series used a special RISC-based power CPU only for AIX machine for running 64-bit architecture, whereas Z-series is used for mainframes. Power stands for performance optimized with enhanced RISC, and AIX stands for advanced interactive executive. Remaining most of the thing I have told in that introductory video related to it. I just don't want to repeat all that because I want to start the new chapter, that is the first chapter after introduction. So basically what happens is, as I have told you, that AIX is specific to hardware. There are many hardware that is related to IBM Power Series, like we have IBM Power 4 Series, Power 5 Series, Power 6 Series. Now these 4 to 6 or 7 series are special series because it includes virtualization inside it. Now as you have told that you have learned virtualization, you are well aware of what is virtualization. So that concept of virtualization was first introduced by IBM in their Power machines, in Power 4 machines. They came out for this kind of credibility, like where you can have multiple machines running in one setup. Then there are some requirements, like if you want to make an LPAR in P4, you require minimum 128 MB of RAM and 1 unit of CPU, and then I can create a LPAR over here and I can start working on the top of it. Similarly, there are P5 requirements, P6 requirement, P7 requirement. Apart from it, if you talk about models comes in tower model as well as rack model. Now basically the model what you see on the screen, Power 6 520 model, this is a very basic level model, or I can say entry level model for a small organization. Similarly, if we go for 550, this is a bit of mid-range model, which would be not that much high, not that much low, high or not low configuration. Similarly, we have 560 Express server, which comes in the form of building blocks. What happens is here the hardware would be very high, and those hardware may not be suffice in one hardware box. So in this scenario what happens is we require two boxes. So particularly this is one machine, but separated or segregated between two physical boxes. This kind of model is called as building block model. So where I would be having number of blocks supporting the same machine. Similarly, I have P6 570, which is again a building block model. Number of blocks would be connected. The bottom what you see is just a block. At the top what you see is the head for it, from where you are going to monitor and manage this particular entire setup. Similarly, you have the highest model 595, which itself would be a big rack. So these are the topmost models that is available in the IBM Power series. Anyway, in any series you go Power 4 series, Power 5 series, Power 6 series, or Power 7 series. The last model inside it would be the topmost model, most expensive and only affordable by the very rich companies, because the cost involved is in millions of dollars. So people may not go for it. Rather than that, they will prefer going with 560, 570, and 595 would be the most costly server and high performance server. Similarly, we have Power 7 model also. So Power 7 model also available in what I can say rack model or tower model. 710 very basic, 720 is a bit of basic again, 730 is also basic, 740 from here you will be having mid-range server, then 770 starts with again high-end models, 780 is also a high-end model, 795 is also a high-end model. So these are the independent physical machines on the top of which you will be having number of machines, number of VMs which we call as LPAs running, and we would be connected from outside and we would be working on the top of them. So again, Power 6 or Power 7 both comes in one more format called blade. In this blade model, the performance will be equivalent to your tower model or rack model, but these models, blade, whatever you see on the screen is only available for basic model. You don't see mid-range or high-end model available. 720, 730, 710, that would be easily available in the form of rack, but when it comes to 750, 770 or 780, that cannot be converted into a rack model. So again, rack model, sorry, tower, this blade model is also a good thing, but it is again only for a small organization who does not have high-end requirement. So here I can have 14 blades in one chassis and I can use it. So this was a bit of introduction related to what IBM Power Series machines would be available. So our work would be completely on Power Series machines. So whatever we have to do it on the power systems, and then only we would be able to work with the AIX. And AIX cannot be installed on laptops or desktops like other operating system. You can go for VMware Workstation or Sun VirtualBox. On the top of it you will install and will practice or something. To work on this, you have to work completely on the server end. There is no other option but to connect to the server and work, because there is no other option to connect to it or install it or manage a home lab kind of environment. Let's see the first chapter after introduction, that would be devices. Now, what is this device? How we have to work with the devices and the different theoretic part related to devices. Basically, what happens over here is devices can be many devices in your machine. You can use CD drive, you can use tape drive, you can use pen drive, you can use printer, scanner, or you can use RAM, you can have motherboard, you can have processors. Lots of things will be called as the devices. So any kind of device you can connect to AIX environment and you can work to it. For example, there are many kind of devices that is available in the market. Like we would be having number of slots. Let's try to talk about slots. So when we talk about slots, there are number of slots that is available. Now when we talk about slots, we have something called PCI slots. We have ISA slot, actually outdated one. Nobody is using ISA slots anymore. And we have something called AGP slots, generally used for what I can say graphic cards. And again in PCI we have a latest one, that is PCI extended one, which is having higher speed than the normal PCI. And when it comes to AGP, we have what I can say some different graphical adapters and everything connected over there. Whereas when it comes to PCI, PCI would be having higher connectivity to it. With the help of PCI or PCI X adapter, we may have network cards connected to it. We may have what I can say, printers, USB ports connected to it. We may be having tape drives connectivity to it. So most of the thing what you will be connecting on any server end, you would see that it would be related either with PCI or PCI X adapter. PCI is the older version and PCI X is the latest version, PCI extended. So any of these would be supported on your AIX environment also. Now similarly, we may be having hard disk. So again in hard disk when we talk, there are various technologies that is available. Very common technology in earlier days, we used to have IDE kind of devices, like you might have seen this IDE connectivity on our normal machines also. We used to have a belt that used to have two types of connectivity. One would be connected to the motherboard, another would be connected to CD-ROM, or what I can say, this hard drive or something. 32 pins would be used to be there over there. So that kind of hard drive is also supported. Or you may be having the latest technologies like, SCSI can also be connected. SCSI is a very common technology that you might be seeing used in AIX environments. Or you may be having serially attached SCSI, that is nothing but SAS. Or the latest technology of the disk, that would be SSDs, solid state drives, very powerful and very high performance devices. And also there is one more technology when it comes to PCI cards, also supports fiber channel, so that from SAN we can get the LUNs. So those FC disks are also available in nowadays. As in the coming classes we may try to talk more about fiber channels, that how it works and how disks can be connected with the help of fiber channels. So anyway, there are many devices in your environment, enormous devices are there, number of things are there that you can connect with that particular thing that can be called as a devices. So all these devices are supported on your power machines and AIX environment. And the thing is, we have to understand the terminology, that how this particular devices would be connected, how it would get recognized, and where it is going to store in the AIX environment, regardless of technology, regardless of what kind of device it is. So let's try to talk about the device terminology. The first thing, so when it comes to device terminology goes like this, that the first thing in the device terminology is the physical device. Now this physical device can be anything. Whatever you are trying to connect to your machine can be considered as a physical device. It can be pen drive, CD drive, tape drive, it can be hard drive, it can be scanner, printer, webcam, whatever it might be, whatever blah blah thing that you are trying to connect physically could be considered as a physical device. But the question arises over here is, where I am going to connect my physical device. So all the physical devices would be connected to one or the other port. For example, if I have pen drive, I would connect it to USB port. If it is a SCSI device, I would connect it to SCSI port. So anyway, whatever the device I am having, I would like to connect it to one or the other port. Now what is this ports? Ports are a device which would be having a built-in software inside it to censor that what kind of device is connected to me. It will sense out that what is the kind of device that is connected to me, and it will try to dig out the information about the device. So ports are the special set of devices that would be having a built-in software to sense out that what kind of device is connected to me, and according to that thing we will try to load a proper driver. So again in the terminology you can see that the first thing that we are connecting is physical device. Physical devices are connected to port, and as soon as it is connected to port, port will try to detect out that what kind of device is connected to me, and according to that a device driver would be loaded. Now I don't have to explain you what is device driver. because it is the most common thing what we see or what we troubleshoot every day-to-day activity. It's a piece of software that is manufactured or that is created by the vendor so that the device can perform properly. Any device, if it is not loaded with the proper device driver, cannot function properly in the system. So any device to function properly, we require a piece of software that is called as device driver. So as soon as I am connecting my physical device to the ports will sense it out and it will try to load the device driver. Now once the device driver is loaded, my device would be given one name that is called as logical name. The best example I could tell you is, assume you have a pen drive. You have connected that pen drive to the system. Now as soon as you have connected the pen drive to the system, it will detect what kind of pen drive is connected to me. According to the type of pen drive, it will load the device driver. Now once the device driver is loaded, if you go into my computers, it will give it some name, C, D, E, F, G, H, whatever it might be. So whatever names what it is giving over there, C, D, E, F, G, H, those are not a real name of the device. It is some logical name, software defined name, so that you can easily identify and you can work with that. So these names what have been given to it is called as logical names, and in Unix terminology, logical devices. It is not the real name, it is just a user-friendly name given to me. So this is how it happens. Physical device is connected to port, device driver is loaded, and a logical name is given to it. Finally, all these logical names are going to be stored on /dev directory. If you go into /dev directory and if you list out the contents, you'll see all the devices which is currently connected to your machine. So all these logical names what are getting generated would be stored under /dev directory, and you can make use of it. So this is how the terminology works when it comes to IBM AIX or generally any operating system, but especially in AIX, this is the terminology. Physical device connected to port, device drivers loaded, given one user-friendly logical name, and that name is getting stored under /dev directory. If you just go to /dev directory, as I've told you, you can see out all the devices that is connected to your machine, and these devices would be having two things given to it. One would be major number and the other one would be minor number. So in this list you can see lots of things are there. While we are doing practical, we will try to talk about this, what is major number and what is minor number. But as far as the summarized way is concerned, I could tell you that major number is the device driver number and minor number is the device number on which this driver is loaded. So you can see in this particular list also, the first thing is continuously repeating, because maybe I am having same type of disk connected, so obviously I would be using the same device driver for all the devices. But whereas if you see in the second list, the numbers are keep on changing because I am having different devices on the top of it where my device driver is getting loaded. Now one more thing I would like to tell you before we can proceed. Well, let's try to talk more about the logical devices and logical names. See what happens over here is in your AIX environment, each device is given some or the other names over here. For example, let me say that I'm having hard disks. So hard disk will be given some names over here, like hard disk will be represented by H disk letter. So here we will be using H disk, and first disk will be given as a name 0, second would be having H disk 1, third will be having H disk 2, then fourth will be having H disk 3. So like that, what happens over here, the naming convention goes like that. If it is a hard disk, the naming convention would be H disk 0, 1, 2, 3, 4, 5, 6, so on and so forth. Similarly, If it is an Ethernet adapter, then the naming convention will be ENT. First would be called as 0, ENT 0, second would be 1, then 2, then 3, so on and so forth. ENT 0, ENT 2, ENT 3, ENT 4, so on and so forth, like that. Similarly, if you have for example tape drives for backup, then the tape drives will be having the naming convention as RMT0, remote tape 0, remote tape 1, remote tape 2, remote tape 3. So this is how the naming conventions would be going. Especially in Unix, you might observe that they will not underestimate 0, they will include 0 in the list. So always the first thing that is getting connected to your machine would be starting with the letter 0. HDisk 0, HDisk 1, ENT 0, ENT 1, PCI adapters will be there, so PCI 0, PCI 1. You may have fiber channel adapters, so FCS 0, FCS 1. So always it will start with 0 as the first adapter, and the second would be having 1. So like this, what happens, some logical names or user-friendly names would be given to each and every device so that we can identify it properly, that what kind of device it is and what is the sequence it is following. Are you following me, Majid?
Yeah, I'm following you. I'm listening.
Okay. Okay. Thank you. So, so we have talked about this logical devices and the naming convention it is having. And if you go into ls-l and /dev, you will see each device situated with their major number and their minor number. Their major number is the device driver number, and minor number is the device number on which this driver is loaded. Similarly, when we talk about the device configuration, so my device configuration is divided into two parts. First is predefined database, and the second one is customized database. So predefined database is nothing but the list of supported devices. Assume that you would like to find out that what kind of adapters are supported to AIX environment, that you can find out from predefined database. You want to see that how many keyboards are supported, you can find it from predefined database. Similarly, you want to see how many what I can say tape drives are supported, how many hard disks are supported. So all that supported list is available in predefined database, whereas we have all the currently connected or maybe once connected and configured devices information in customized configuration. So customized is actually user defined, and predefined is something which is already available by IBM. When you install the operating system, this list will be available from where you can find out that what kind of devices is supported, maybe Ethernet adapter, tape drive, CD-ROM, printer, scanner. So it is all a big list of the supported devices in AIX environment. Let's talk about, as we have started talking about device configuration, let's try to talk about one of the most important elements in your AIX environment. So generally, what happens is we call kernel as the heart of operating system. It is indeed heart of operating system. If the kernel crashes, the entire operating system will be crashed down. But there is one more object, especially in AIX environment, which is equivalent to your kernel, that we call as ODM in short, and the abbreviation is Object Data Manager. Now this Object Data Manager, you can consider it as brain of AIX or the entire database of AIX. This ODM will try to maintain the configuration that is related to the entire system. It keeps information about many things, but mostly it will try to keep information about system configuration, devices, vital product data, very important information related to your devices that is connected to it. Lots of information would be maintained by ODM, like it would be keeping information about devices at the top. It will keep the software information, It will keep the information about the services that is running in your machine. It will keep the information about the TCP/IP or Ethernet kind of entire environment. It will keep the information about the menus and commands related to SMIT. SMIT stands for System Management Interface Tool. Now what happens in AIX is, to perform all the mid-level or high-end commands, we require one interface. See, what happens is, unlike other Unixes, you don't have to remember that lengthy commands all the time. What we can do is all the medium type of task or high-end kind of task, you can do it with the help of a very user-friendly tool called SMIT, System Management Interface Tool, where I can do all the management activities like configuring a disk, unconfiguring a disk, installing a software, uninstalling a software, creating a user, deleting a user, or performing network installations. Lots of high-end and intermediate tasks you can do it with the help of SMIT, even if you don't know any command. So that is the beauty of AIX, which provides wonderful tool to work with, where you don't have to remember all that complex commands like other Unixes or Linux. So ODM maintains its total information in 3 important locations. Now those 3 important locations are called as repositories. So these repositories are the location where ODM will be maintaining the total information about your system. Now what are those locations? These locations are etc obj repos, usr lib obj repos, usr share lib obj repos. So what is the information that is maintained in etc obj repos? It contains the information that is totally unique for this current operating system, the local information about your system, how many devices are there, how many devices are connected, how many device was once connected and configured and currently maybe not connected, maybe not powered on, how many software I have installed, what is the current version of the software, all the important data. So all in all, the entire local operating system information is maintained inside etc obj repository that is unique only and only for your box, your LPAR, your VM. It will store the information about that. Similarly, there might be number of occasions where I may be connecting to other AIX environment. For example, in my environment, I may be having number of AIX machines working for communication purpose, file sharing purpose, or anything. I may be connecting from one AIX machine to other AIX machine. So what is the kind of information that has to be stored between same architecture whenever I am trying to connect? That information is stored under usr lib obj repository that contains the information which can be shared among machines having the same hardware architecture. That is nothing but power machine to power machine. Same AIX family. If I am trying to connect from one machine to other machine, then what kind of data that would be shared between both of them, that would be stored in usr lib obj repository. Now as we may be connecting to same architecture, same family, there is a huge chance that I may be connecting to different architecture and different families also. From AIX I may be connecting to HP, from AIX I may be connecting to Linux, from AIX I may be connecting to Solaris. So I may be going to different architecture and different what I can say families of operating system also. So the data that can be shared between these things would stored under usr share lib obj repository, which contains information which can be shared among machines having different architecture like various Unix operating system, dump terminals, or diskless clients. So these are the 3 important repositories that ODM maintains to know the entire information about your system and the other machines to which I am frequently communicating. Out of three, the most important is the first one, that holds the information about the current machine or my complete operating system and entire thing connected to it. So
Is it like the program files we install on Windows?
see, what happens over here is program files is bit readable, but here what happens is, ODM is not readable. In Windows, what happens, you have different things, like you have device manager containing all the device information, program files keeping information of the software, Windows folder, it will keep the drivers information. So everything is scattered over there. But in AIX, what happens is, all that thing is maintained by one object, that is ODM and the repository. Okay. Am I clear, Mujib?
Yeah, you're clear. Thanks.
Okay. Right. So this is how we can try to work with that. Now, to work with ODM, Object Data Manager, I require one more important manager over here, and this manager is called as Configuration Manager. Now, what is this Configuration Manager? Let's try to talk about it. Basically, Configuration Manager is represented by Cfgmgr. Now, Cfgmgr is an abbreviation or a short form for Configuration Manager, but it is also a command. See, what happens over here is, whenever I'm trying to connect any new device to my machine, what happens in Windows is, if you connect any device to your machine, automatically it will start detecting that what drive is connected to me, and according to that it will try to load the drivers. But unlike that, in AIX, whenever I wanted to connect any new device and configure it, I can connect the device, but to configure it, I have to use the command Cfgmgr. So when I use this command Cfgmgr, it will thoroughly scan the entire system for any new object added to my system. If it finds any new object added to the system, it will try to configure that device with a proper driver. But how it will get the driver? To get the driver, again, it has to consult ODM, because the entire system information is maintained in ODM. All the supported drivers, everything is over there. So Cfgmgr will only detect that what is the kind of device connected. According to the device, it will go to ODM and it will get a proper device driver. It will try to load that driver for installation. So whenever you are trying to add any new device to the system, connect it and run Cfgmgr so that it can detect and it can load the drivers for it, and the device would be available for use. But Cfgmgr is only automatically executed once, that is also again at the time of booting. So Cfgmgr is automatically executed only at the time of booting. But if any new device is attached to the server while it is up, then we have to execute this particular command manually. Most of the time, any new device, maybe it is a SAN LUN that is coming to your machine, we will contact to SAN engineer, will say that we require 10 GB of LUN. So he may give us 10 GB of LUN and he will approve me that I've got 10 GB of LUN. Now if I want to see that on my machine, I'll use Cfgmgr to detect it, configure it and make it available for use. So all in all, any new device which is connected to my machine, if you want to configure it, you have to go through with the command Cfgmgr, which is only executable automatically during the time of boot. Rest of the time, whenever any new device is attached, we have to run this command manually and get it configured. Now, what are the information that is maintained inside ODM? As already I have discussed one more time. First thing, devices information. Second thing, all the software information, SMIT menus, NIM information. NIM stands for Network Installation Manager. So this Network Installation Manager is something via which, being on one machine, I can install the operating system on the other machine. or I may update the software on other machines. So it's a centralized installation manager via which I can perform updates, via which I can do installation, something like update manager in your VMware.
Yeah.
Right. Similarly, what happens is in ODM, it also maintains the information about error log and dumps. It will keep the information about multi-path input-output if we are having this coming from SAN. Also, it will keep information about TCP/IP and the configuration, that how many Ethernet adapters are there, what is the IP addresses I have assigned, all that thing. System resource controller. System resource controller is nothing but the services that would be running in your machine. That would be SSH service, HTTP service, Samba service, or SNMP service. Any service that is running in your machine is called as system resource controller. Generally, we call it as service. In AIX, we call it as SRC or system resource controller. So all these information is maintained inside ODM in a very closed manner. See, what happens is, if you are working on Linux environment, everything is available in flat file. You can just go into that particular file and you can see what is the details regarding Ethernet adapter, devices, everything. But when it comes to AIX, it is quite closed for security reason. So nothing is open here. Everything is maintained very closely and tightly inside ODM. Without any command, I cannot make use of it. Like in Linuxes, we can open the file and we can start working with it directly, and we can make any configuration changes. One more important thing is here, device states. So this is also one of the important thing, and again very much dependent upon your Cfgmgr or configuration manager. So let's try to talk about it over here. When it comes to states, there are three types of states: predefined state, defined state, available state. So out of these two, as in the beginning we have seen that there are two types of configuration database: predefined configuration database, customized configuration database. So in your predefined configuration database, you will only see the information about predefined devices. Predefined devices are nothing but supported devices, only the list of supported devices. This kind of state is actually an informative state where the device is not connected to the machine. It is never connected to the machine. It is only a piece of information available in the supported list where I can go and I can find out that what kind of device is supported on this environment. So it is only an informatic kind of state where information is maintained that these are the devices that you can attach to your machine. Whereas the important database is customized database. In customized database, I have two states: defined state, available state. Any device is called as defined device when it was once connected, configured, but currently it is not connected or maybe powered on. The best example of defined device I can give you is a printer. See, we may have a printer connected to our machine, and obviously all the time we may not power it on and we may not keep it running. So the time when the printer is powered off, it will show my printer as offline, but information is still maintained in the machine. It does not say that this printer is not available. See, once you connect the printer or pen drive or any device, for the first time only it will detect and it will try to load the drivers. Once the driver is loaded successfully, you remove and reconnect it. Next time it won't take that much of time. The reason is information is already maintained in the system. So that information is called as defined state. So in this state, what happens is the information is available, configuration is available, but the device is missing. Maybe I have not powered on the device, or maybe I have not connected it. So this situation of the device is called as defined state, where the device was once configured, connected. Currently it is not powered on or connected. This kind of device is called as defined device. Now either it is predefined device or defined device, both are not usable state, because here the device is missing, here the configuration and device both are missing, so I cannot use it. But the final state that is available over here is available state. This state is also called as ready to use mode or ready to use state. See, what happens over here is, in available mode, the device is connected, configured, and currently available for use. So these are the state of the devices which is currently usable in your environment. Now I can play with these states whenever I want. If I wanted to move any device from available to defined, for example, I want to break the connection to the device for a temporary period of time. Assume that I am removing the device for a while. Now I would like to safely remove it. To safely remove it, what I'll do is, I'll put the device from available to defined, so that I may remove it physically for a while and I can reconnect later point of time. So any device, if I want to move it from available to defined, then I will go with the command remove device rmdev -l. L represents the logical name of the device. You will give that name and automatically your device will be moved from available location to defined location, where it will put you in safely remove condition, where I can physically remove my device and I can reconnect it to other location. Again, after my work is over, I have reconnected my device to my machine, and if you have reconnected it, to bring it back from defined to available mode, you can use Cfgmgr. So as soon as Cfgmgr is run, it will see whether the device is connected and available. As soon as it is connected and available, it will again bring it back into available mode. Sometimes we may completely want to remove the device. Maybe the drivers are not loaded properly, and every time whenever I am connecting the device, it is giving me lots of issues. So what I would like to do is, I would like to completely remove the information about the device even from my database, even from my ODM, so that next time when it is connected, freshly the drivers should be loaded. So in this scenario, I will completely remove the device information even from ODM. To do this activity, we will go with the command rmdev remove device -d and then L. D stands for delete the information from ODM also. So when you say remove the information, the total drivers and all the information that was stored about it will completely wipe out from ODM. So next time when you run Cfgmgr, it has to freshly configure it with new drivers and all new things whatever related to it. So like that, what I can do, I can play with all these states. Whenever needed, I can put it into predefined mode, or most important modes, defined mode or available mode. But anytime my device is in predefined or defined, that means it is not usable state. The device can only be in use if it is in the available mode. Am I clear, Majid?
Yeah, you're clear.
Okay. No doubts up till now?
No, it's like installing and uninstalling, right? Most probably.
Installing and uninstalling, you can say up to one extent. Or what I can do, what I can tell is, you can go to device manager and you can uninstall the driver.
Okay.
Like that. And specially defined mode is safely remove mode, where what you will do is you will right click on pen drive, you will say safely remove, it will put it into defined mode, disconnection mode, and you can remove the hardware safely. Whereas predefined and available moving is something like uninstalling the driver and again installing the driver.
Yeah, I got the concept here.
Okay, good. Now let's try to talk about that as soon as you run Cfgmgr, how the device would get configured. Assume that I have a CD-ROM which I have connected to my machine. Now as soon as you have connected, you will obviously run the command Cfgmgr. Now as soon as you have run Cfgmgr command, it will ask the CD-ROM the first question, who are you? For which CD-ROM would answer that I am a CD-ROM device connected to this location. The location what it is displaying over here is called as logical address or logical location, software based address. So as soon as what happens over here is, as soon as it find out that what kind of device is connected to me, it will move this device into defined state where it will make an entry related to CD-ROM. It will make an entry in ODM saying that I found out one CD-ROM which I am going to give a name CD0. It can be any name. If already one CD-ROM is existing, then it will give it CD1. If two exist, then CD2 kind of thing. So here it will put an entry in ODM saying that I found out one CD drive and still the drivers are not loaded for it, so keep it in the defined state so that it may not be usable, and obviously it cannot be usable until unless the proper device drivers are loaded. Then it will go into device driver database inside ODA. It will find out that what kind of device driver can be given to it, and according to that it will find out a proper device driver and it will assign those two important IDs to it, major number, minor number, where major number would represent the device driver number, minor number would represent the device number or device on which this driver is loaded. Then it will make an entry in /day. See, as I've told you at the beginning itself that all the devices information is going to maintain inside /day. So up till now what happened over here is it wasn't having any device driver. What happened is we had a CD-ROM, we run Cfgmgr, questions asked, answers received. Now once the answer is received, an entry in ODM got created, but it was still in the defined state with the software location that where it is connected. Then it went to device driver database, it loaded the device driver, and an entry has been created in /dev directory that this is one of the device which is now going to be used in CD drive. Now once the device driver is loaded properly, the last thing it will do is it will move it from defined state to available state. Now it is available, we can make use of it. So this is how what happens is my entire device configuration goes through. First the question will ask, second the device will answer. Then it will put into ODM as an entry in defined mode so that it may not be usable until unless the device driver is loaded. Once the entry is available, it will search for device driver. Once driver is found, driver is loaded. Once driver is loaded, /dev directory, one entry will be created. Once entry is created, finally it will put into available mode, and now you can start using it. So this is how what happens is my device would get configured whenever we run Cfgmgr command. Similarly, let's try to talk about your device addressing. Now what happens over here is when it comes to device, your device would have two types of addresses. One would be logical address, software based address, where you can find out that logically or software wise this device is connected to which SCSI, it is connected to which bus, whether that bus is internal or external, and how it is getting connected, or you can find out one more address over here that is called as physical address. So physical address will actually tell you the physical location, that where it is connected, the device is connected to which PCI slot is connected to which motherboard, and that motherboard out of all blocks. Just now we have talked about that AIX machines comes in building block models also. So all blocks will be having one motherboard. So it will tell you that this particular adapter is connected to which block in which motherboard. So physically how it is connecting and logically how it is connecting. Both kinds of addresses are available in your ODM. So with ODM I can find out that logically where it is connected and physically where it is connected. Logically for end user, for our usage. Physically, if you want to remove it or manipulate it physically. Now if I want my system engineer to check for one particular device or to remove it or to reconnect it, then in that scenario I will require physical address. But to connect it logically, to connect it inside operating system, I will require logical address. So this is how we are going to work with the logical address and the physical address. So whereas if you talk about the logical address will tell you that where it is connected, how it is connected, especially the format what it follows is something like this: A, B, C, D, E, F, G, H. If I take you 2 slides back, you can see over here there is some address A, B, C, D, E, F, G, H. So in this order we will try to identify it. First 4 characters would be only normal addressing, like A, B, C, D will identify the bus and the adapter location. Either it might be SCSI or it might be non-SCSI device. First 4 letters will only identify that what kind of bus is connected to my machine. EF will tell you whether it is connected to single bus or whether it is connected to dual bus. Now again in bus, it can be internal bus that is connected directly via motherboard, internal connection or built-in kind of hardware, like you would be having built-in Ethernet adapter, built-in what I can say monitor adapter, serial adapter. So if it is an internal bus connected internally within motherboard, then it will display 00. But if it is an external bus, like with the help of adapter we will connect it to the outside or something like that. Especially in SCSI it happens that you would be having one cable and that cable will be connecting almost 14 or 15 or 27 target. One big SCSI cable would be there that would be having number of connectivities over there. So each thing will be called as a target over here. T0, T1, T2, T3, T4, T5, like that number of things will be having. T0 will be connected to motherboard, and from there everything will be connected to multiple devices. So these would be considered as the external bus, where what happens is I have a medium of cable or something via which my things are connected. So if it is an external bus, it will show you 01. If it is an internal bus, then it will show you 00. So as you can see out over here, first 4 will tell you about the adapter ID. Second thing will tell you 00 as an internal bus or external bus, and either in external or external whether it is dual bus or single bus. Finally, you'll see last 2 character G, which will tell you SCSI ID, H, logical unit number of the device. So probably this is just an information. Hardly we will bother that what is this location code or what A, B, C, D, E, F, G, H inside it will do or what it matters to us. Whenever we need, we only run a command and we will find out that what is logical address. And the same address will be given or will be used directly. And the same thing you will be having in the physical address. The only difference is logical address, at least we can talk about these things, that what is that A, B, C, D, E, F, G, H. But when it comes to physical address is only understandable by IBM Power Series Hardware Engineer. If you go for hardware course related to power machine, in that they will teach you those codes related to power hardware, like it would be P1, T1, Z1, lots of things will be there inside it that they will try to understand. Like if it is T, starting with T letter, that means it is a built-in kind of thing. If it is starting with C, then it is something external, card 1, card 2, card 3, like that. So they will try to understand better. What we will do is we will only give that physical address, they will decode that address, and they will try to better utilize that address for removing or making any changes on that particular location. So theoretical part is almost finished. The next thing what I need to do is we need to log in into the system and we have to do the practicals. So as of now, what happens over here is the servers are not available for today, but what we will do out over here is tomorrow when we start talking about the class, we will probably complete the practical part where I'll try to teach you the entire practical setup, like how the commands would be working, how SMIT would be working, how to see this predefined database, how to see the customized database, and also how to find out each and every predefined device, customized device. Lots of interesting practicals are there, so which probably I'll try to show you tomorrow. As of now, if you have any doubts, you could ask me, Majid.
It's pretty clear actually. I mean, I don't have doubts, but probably I'll go through the material today, and if I have any doubts, I'll come tomorrow. Sure.
You can just go through this particular thing. If you have any kind of doubts, you can put forward your doubts. We will try to find that out. And this thing would be going like this only. We would see practical and the theory and the practical at the same sessions. And I would make sure that the servers would also be available at proper time so that we may not have to wait as what we have to do today. So we'll finish the class today, Majid, and tomorrow we will try to meet up. One more thing I would like to ask you, is it possible for you to join this class in morning time of India?
Yeah, that's fine. I mean, that will be really great.
So is it possible for you, Majid, that could you come at 6 a.m. of Indian time?
6 a.m. would be my 7:30 p.m. Yeah, I'm at Central Time.
Give me a time at what you are available so that I can plan.
You know what? I'm 10.5 hours ahead. Actually, I'm in Central Time Zone.
Okay.
So not even 10, 12.5, I guess. Let me check. If it's 6 o'clock there, it will be 7:30 my time. So I mean, as per your convenience, I can go anytime because I'm available for 2 weeks. I'm not in any job or anything right now. So next 2 weeks depends on what time you are available. I mean,
I'm having no problem. See, anyway, we have to. I'll be available after Fajr. So 6 would be a proper time over here. Almost 5:30 something. Fajr prayer will be over. Namaz ho jati. I'll be available at 6. So अगर आप 6 बजे तक available हो तो
अच्छा है ना, मेरे 7:30 होते रहते हैं, I mean evening के, और time available होता हूँ मैं घर पे.
So that is better now, भाई. Then is it possible tomorrow? Can you come by that time? I mean maybe abhi it's your morning, right?
Yeah, it's my afternoon right now, 12 p.m. So
12. So is it possible?
Yeah, it's possible. Evening, मेरी आज evening हो गई again. That's fine.
Evening मतलब मेरे पास कल सुबह हो जाती, आपके पास जो है ना evening रहती है.
Yeah, that's great. अच्छा है ना?
Okay, तो मैं एक काम कर लेता हूँ कि I'll make sure that servers are available. So आपके evening time में we will see the practicals.
Okay.
Okay.
And I was thinking, आपको जितना time आप extend दे सकते हैं every class so that I can finish ASAP.
इंशाल्लाह उसमें कोई मसला नहीं है. इंशाल्लाह मैं 6 बजे इसीलिए वो टाइम लिया क्योंकि जो है ना एटलीस्ट मैं 6 को भी अगर शार्प स्टार्ट कर रहा हूँ तो 2 घंटे से ज़्यादा मैं वहाँ पे आपको टाइम दे सकता हूँ. इंशाल्लाह देखेंगे हम लोग वीकेंड्स वगैरह पे अगर थोड़ा ज़्यादा टाइम स्पेंड कर सके तो बैठ के we will try to finish it as much as possible.
Okay, and from my side, I'm totally flexible. जैसा आप, sometimes you're busy, something comes up, कुछ आ जाता है, so you can let me know so that we can, change the time.
इंशाल्लाह अगर ऐसा है तो I would definitely try to inform you. और as of now तो ये टाइमिंग ज़्यादा मेरे को suitable है. 6 बजे मैं इंशाल्लाह जो है ना रेडी रहूँगा सुबह में, तो we'll see the practicals then tomorrow.
Okay, thank you.
Okay, चलो ठीक है मुझे जी.
Okay.
Thank you.
Thank you.